Today we will continue our first chapter, that is matter in our surrounding. Our today's topics are boiling point, latent heat of vaporization, sublimation, evaporation and so on. Before starting boiling point, let us understand the meaning of boiling. What is the meaning of boiling? Boiling means converting the liquid into gaseous state. Suppose I am having a liquid with me and I want to convert that liquid into gaseous state. I will supply heat to it. So it will reach to the temperature of 100 degrees Celsius and then the boiling starts. So what is boiling? Conversion of liquid into gaseous state at its boiling point at given atmospheric pressure is known as boiling point of that liquid. Now what is boiling point? So boiling is a process. Now what is boiling point? Boiling point means that temperature at which the liquid starts converting into gaseous state. That temperature is known as boiling point. Now the boiling point of water is 100 degrees Celsius is equal to 373 Kelvin. Now suppose I want to, now we know that 0 degrees Celsius means 273 Kelvin. Suppose how to convert the Celsius into Kelvin and Kelvin into Celsius. For example, you are given 55 degrees Celsius. I want to convert 55 degrees Celsius into Kelvin. So what I will do, I will add 273 to this number. So I will get Kelvin, that is 328. If I will do the addition of this, I will get 328 Kelvin. Now suppose you are given 500 Kelvin and you are told to convert that into Celsius. So what I will do, I will write 500 minus 273. It will be equal to 220 degrees Celsius. So 500 Kelvin is equal to 227 degrees Celsius. So in this way, we can convert the Celsius into Kelvin and Kelvin into Celsius. Okay, now our next topic is what is latent heat of vaporization. Now we had already learned the latent heat of fusion. Fusion means conversion of solid into liquid. And vaporization means liquid into gaseous form. So, if I take 1 kg of water, 1 kg of water and I want to convert that 1 kg of water into vapors, I have to supply heat. So, what is latent heat of vaporization? The amount of heat required to convert 1 kg of water into vapors at atmospheric pressure at its boiling point is known as latent heat of vaporization. It's just like latent heat of fusion. But in fusion, we are taking 1 kg ice and it is converted into liquid. Here we will take 1 kg water and it is converted into vapors. Okay, now before starting sublimation, let us understand this concept. If I want to convert the solid into liquid, I will heat it. If I want to convert liquid into gas, I will heat it. Okay, if I want to convert the gas into liquid, I have to reduce the temperature. That means I will cool it. If I want to convert liquid into solid, again I will cool it. That means on heating, the state of matter changes from solid to liquid, liquid to gas. And on decreasing the temperature, the gas converts into liquid and liquid converts into solid. Now, is there any possibility that we directly convert the solid into gaseous state? Yes. In some cases, we don't get the liquid state. Directly solid is converted into gaseous state. You are knowing about camphor. That is kapoor, which we are using in puja and all that. Let me show you the kapoor. Okay, so this is kapoor. Okay, that we call camphor. Now, this is in solid state. If I will heat it, it will not get converted into liquid, but it will directly convert it into vapors. So, that process in which solid directly converted into gaseous state, that method is known as sublimation. So, sublimation is a process in which the solid states directly converts into gaseous state. Okay, now is it possible to convert the gaseous state directly to solid? Yes. and that process is known as deposition process. That means if I reduce the temperature of gas, it directly converts into solid instead of converting into liquid. For example, if I take the vapors of this kapoor or camphor, what will happen? It will not get converted into liquid. It will directly come back in the form of solid. So that process of conversion of solid into gas directly is called sublimation, and gas into solid by reducing the temperature is known as deposition. So solid to liquid, fusion. Liquid to gas, vaporization. Solid to gas directly, sublimation. Gas to solid, that is deposition. Now our next topic is evaporation. You are familiar with the word evaporation. Suppose I take a wet cloth and put it outside in sunlight. After some time, that cloth will get dry up. Why this is happening? This is happening because of evaporation. That means the water particles get converted into vapors and get removed from our cloth. Now the question is, what is the difference between boiling and evaporation? Now see, here boiling is also what? Liquid converts into gaseous state. In evaporation also, the liquid is converted into vapors. Now the difference is, boiling is a process which takes place at the boiling point. For example, in the case of water, it starts at 100 degree Celsius, or we can say 373 degree, Kelvin. Okay. But in evaporation, the liquid get converted into gaseous state below the boiling point. That means at any temperature below the boiling point. So when you are putting your clothes outside, when you are keeping your wet clothes outside, they are not reaching the boiling point of water but get dry up because of evaporation. So what is evaporation? The process of conversion of liquid into vapors at any temperature below boiling point is known as evaporation. So that is also a process in which liquid converts into gaseous state. Now, what are the factors affecting the evaporation? Okay, this is the wet cloth and I want to dry this cloth. So what I will do? What your mother is doing with the cloth? She spread the cloth and then put it in the sunlight. If she will keep like this, then it will dry up fast? No. So, if I want to increase the process of evaporation, the surface area must be increased. If I keep it like this, the surface area is less, but when I spread the cloth, it dry up very fast. Why? Because the surface area is increased. When we increase the surface area, the process of evaporation increases. So, increasing surface area increases the process of evaporation. Evaporation also increases. So, this is the first factor. Which is the first factor? Surface area. Surface area increases, evaporation increases. Second is temperature. Suppose temperature increases if you keep your wet cloth outside in a sunny day or in winter season. There is a difference in time. Now, in sunny day, what happens? The temperature is more. So, if the temperature is more, evaporation is more. That means if the temperature increases, the process of evaporation also increases. The third factor is humidity. Humidity means the moisture. If the moisture increases, if the moisture is too much in the atmosphere, your wet cloth will dry up fast? No. In that case, evaporation decreases. So, if surface area increases, evaporation increases. Your clothes dry up very fast. If temperature increases, evaporation increases. But if humidity, that is the moisture, increases, evaporation decreases. And the fourth factor is wind speed. You had observed that if it is windy day, if wind is blowing very nicely, your clothes dry up very fast. That means evaporation takes place very fast. So, if the speed of wind increases, evaporation also increases. So these are the 4 factors on which evaporation depends. The first is surface area, second is temperature, third is humidity, and the fourth is wind speed. If it increases, evaporation increases. If temperature increase, evaporation. But in the case of humidity, moisture, if humidity increase, evaporation decrease. And if the wind speed increase, if the wind blow very nicely, evaporation increases. Our next topic is effect of change of pressure. We had learned about the temperature. Now we will learn about the pressure. Suppose I had taken a liquid. Okay, the more particles are moving like this. There is a more space as compared to the solid. Now, if I exert pressure on these particles, what will happen to these particles? The particles will come close and the liquid will get converted into solid state. That means if I increase the pressure, the gaseous states converts into liquid. And even still I keep giving the pressure, liquid will get converted into solid. That means if the pressure increases, the state of matter changes. That means in gaseous, the particles are very away from each other. So when you are giving the pressure, you are bringing the particles close to each other. So when they come close to each other, they become liquid. Again, you are giving pressure, you are taking the particles more and more close to each other. In that case, that liquid will get converted into solid. So by increasing the pressure, we can convert the gas into liquid, liquid into solid. Now the question is it possible? The same way, if you decrease the pressure, solid get converts into liquid and liquid get converts into gas. If you decrease the pressure, if you increase the pressure, gas into liquid, liquid into solid. Now the question is it possible to convert the gaseous state directly to the solid state? Yes, in some cases. Suppose you take carbon dioxide. It is in a gaseous state. If you give too much pressure to this gas, it doesn't get converted into liquid. It directly converts into solid state. And that solid state is called dry ice. So what is dry ice? Solid carbon dioxide, that is the solid form of carbon dioxide, is called dry ice. Now, when you decrease the pressure, this dry ice will not get converted into liquid. It will directly convert into gaseous state. So, gaseous state can be directly converted into solid state by giving pressure. And by releasing the pressure, again the solid can be converted into gaseous state. So I think the effect of change of pressure is clear. So pressure also plays an important role in changing the state of matters. Now our next topic is evaporation and cooling. How the evaporation gives the cooling effect. So let's try to understand by taking acetone. Acetone means a nail polish remover. Okay, this is acetone, the nail polish remover. If I take this nail polish remover in my hand, So when we take acetone in our palm, what happened? We feel cooling effect. You had observed this thing whenever the girls are putting nail polish remover in their nails. Now, why this is happening? Actually, when I am putting the nail polish remover here, evaporation takes place. So, the acetone, the nail polish remover, is taking the energy from my palm, the heat energy from my palm and from the surrounding and giving the cooling effect. So, evaporation always forms a cooling effect. You are knowing about the desert cooler. In desert cooler, what we do, we put water. So the evaporation of water takes place and keep the surrounding cool. Now the next thing is, in summer season, we people put the water in an open place and even sometime on our terrace also, so that the evaporation of the water takes place and make our surrounding cool. So because during evaporation, the heat energy is taken from the surrounding. So the surrounding become cool. Okay, now the another question is, why we prefer cotton clothes in summer season? we prefer cotton clothes. We wear cotton clothes in summer season because cotton clothes are good absorbers. They absorb the sweats which is happening in our body during the summer season. Okay, now that cotton cloth will absorb the water molecules which our body is producing. Now the evaporation become easier from that cloth. So it's very comfortable to wear cotton clothes in summer season because evaporation of sweat will be easier when we are wearing the cotton clothes. Now the third thing. Okay, I had taken the chilled water inside this glass. There is no any leakage. Still I am getting the water vapors outside. From where these water vapors are coming? You had also noted this thing. If you take a very chilled water or ice in a glass, the water droplets are formed outside. Even there is no leakage. So from where these water droplets are coming? Actually in the atmosphere, the gas contains water vapors. That water vapors when come in contact with this low temperature, here the temperature is very low because this is very chilled water. So the vapors, the gaseous state of vapors get converted into liquid state, and so we are getting the liquid state of water. So this is all about the first chapter. If you have any query related to this chapter, you can ask me in comment box or on my personal number. Thank you.